Okay, so hello and welcome. Today we start a new topic known as system design. Now, system design is one of those topics which is a hot favorite among interviewers, be it in placement or internships. Now, this topic is not often dealt in great detail in colleges or during colleges, but you can use them in hackathons and make up large scalable systems, or in jobs or while in jobs, people are often using these machineries or these architectures, and this is what people generally deal in large industries. So today we deal about a new topic known as system design, and it's just a gateway course, note that. So we won't be dealing much into this. So let's get started. So system design is the process of defining the architecture, modules, interfaces, and the data for a system to satisfy specified requirements. System design could be seen as the application of systems theory to product development. Well, a very formal definition, but it was just for the sake of defining this process. Let's get to the real life scenario. Now, for instance, I am a machine learning engineer, and I have worked so hard in scaling my machine learning model, defining the machine learning model. Okay, if you do not get these terms, no, don't worry. If you want to check out machine learning, we have our own series in the Young Classroom. Do check that out. So right now, let's deal with this. So I have a machine learning model out here. Now I want others to use it, because a machine learning model in my own system is of no use to me if others don't use it. Like, I want my friends to use it, or I want my other people to use it, right? So how do I make this thing available to everyone? One thing could be, I could use a machine or a laptop and ask each and every friend of mine to come and visit my laptop, use it over there. Not a very viable solution, but okay, can work. What next that we could do is, we could use a laptop or a server out here, and people with their phones could be using this machine learning model easily. A viable solution, and it can be worked on. So in practice, we communicate in servers and in clients. So this thing where I'm deploying my algorithm or my machine learning model or any other algorithm, I call this a server model, right? And my friend who wants to use this, I call it a client model, right? So a client and a server communicate, and thus forms a network of communication between these two entities. And so my friend would be then communicating with this server using this machine learning application, and then getting the results back somehow. Now, the way in which they communicate is often known as HTTP protocol, often stands for Hypertext Transfer Protocol. Do look it up on the internet. And so what it does exactly is that the client over here sends a request that, hey, I want to use your algorithm. Now, if the request is successful, or this server agrees that okay, you can use my server, or you can use my algorithm, it says okay, fine, use it, and then it immediately sends that okay, I have been allowed, with a promise error of 200 perhaps, saying a 200 number, saying that this has been allowed. Now after this has been processed, the client again says fetch me the results, and so after this has been processed, the result gets back. This was a very naive explanation of how the HTTP works, but yes, it explains a bit of what we want. Now there arises a problem. The problem that arises is that this was one machine which was accessing this server out here. I could have 10 different machines, right? Or I could have 10 different clients, or I could have 100 different clients. And if my machine learning model is very popular, I could have 1,000 different clients. And this could lead to 1,000. Now this has to be handled by the server, right? Because every time you put in a request to your server, you are actually engaging that server out there, and so you do not want it to happen. And that is why we need to handle this server efficiently. The server should be handling all these requests efficiently, because there would be a time when this friend of yours was able to use it properly, this friend of yours would be able to use it properly, but because of the large queue, this friend of yours would not be able to use it. And so if, for example, you are in a business startup, you do not want this to happen. You do not want your customers to actually go back empty handed, right? You would be incurring huge losses in that case. So today we'll be showing you how you can actually scale up or scale down your systems, and we'll be dealing some methods. So before we get in the topics of scaling, or advanced topics of scaling, let's take the example of a pizza shop. So suppose you are a startup, you have an idea to innovate a new type of pizza, and you have a secret ingredient and you want to start a pizza shop. Okay, so you started a pizza shop out here, and you are the chef over here at present. So you are handling all the requests. Like for example, you have got customers, right? You've got a lot of customers out here. So initially you attracted perhaps 3 customers, and they liked your idea and they liked your taste of pizza, and so your customers day by day increased. But the point is that, so you are a chef out here, so you decided that I want to increase my profits. You see that people are liking your pizza, so what you did was you increased your time hours, you increased your time working hours, you decreased the time to spend with your family, and you are totally engaged to an extent that out of 24 hours in a day, you are investing 22 hours in a day, right? Lack of sleep, everything. So you are somehow able to support about 10 users per hour, 10 people per hour. Okay, now the thing is that your pizza is so nice, it is such a nice tasting pizza, that you do not that 10 users is a very small or a petty amount. You do not want others, and so after sleeping for 20 after waking for 22 hours, working for 22 hours, you are still not able to get up more people, get up further, able to access more, support further users or further customers. So what you do then, you got an idea, a very obvious solution. You hired more chefs. So instead of you working 22 hours a day, you hired 3 more chefs, and these are working for you day by day. And so now, with all of these working for 22 hours a day perhaps, or out of 24 hours, they are able to support perhaps 200 users per hour. Just an approximation, right? And so you can see out here that how you from 3 you have scaled yourself to 200 users per hour. So that is where we discuss about vertical and horizontal scaling. So vertical scaling was when you actually increased your own efficiency. You increased your time from perhaps 10 hours to 22 hours, and that was vertical scaling. Horizontal scaling, on the other hand, is when you actually increased the number of your chefs, and so the work got divided. The work was not divided, but the customers got divided, and so you were able to support a larger user base. So let's deal with what is a vertical scaling. So vertical scaling on technical aspect deals when you actually upgrade your server. So initially you perhaps would be using 1.1 gigahertz server, gigahertz, and 8 GB RAM server to support your machine learning model or any other model. Now, as the user began increasing, you increase yourself to perhaps 7 gigahertz processor, maybe Core i9, some sort of Core i9. You increase yourself to 64 GB RAM, and so you are actually, increasing or upgrading your server. But what else you can do is that was vertical scaling. Horizontal scaling would be when you increase the number of your servers, right? So all of these servers have this same configuration, but it is only that you have increased your servers or you have scaled out, right? As you can see the term out here. And for vertical, it is scale up. I hope you now got the intuition and what exactly is vertical and horizontal scaling. So now everything has got a pro and a con, right? So let's deal about that. So that was the first definition, as it says, very obvious. Now horizontal scaling is not very easy to implement. You need a lot of techniques to actually guide your customers to this resource, to this server, and so on. It is a little bit difficult to implement, but once you have done it, you can easily support larger user base. Of course, vertical scaling is very simple. Just buying a new server, just adding more resources. So now horizontal scaling can be costly. Vertical scaling can also be costly. It depends, right? But naturally, or traditionally, horizontal scaling is costlier at many areas. So that is one of the things that you need to look after, and it takes more time to be done. Horizontal scaling is not so easy to implement, right? But there is one thing which horizontal scaling actually is better than vertical scaling, and that is that it actually supports a larger user base, and which is indeed one of the pros of horizontal scaling. And so if you are a small startup, or if you are a startup which has got got a lot less resources, you should initially opt for vertical scaling, and then you should go for horizontal scaling. That is what the practice actually is. Of course, you can easily start from horizontal scaling in today's area by using services like AWS and Azure, but just for instance, if you are starting anything from scratch. So now we deal up. So now, for example, your business, or let's get back to the pizza model. So your pizza shop was extremely successful now, and now it was so successful that you opened a shop over there. Now you are not able to handle it in a single location, like users so you open different branches of the pizza house, right? Now what happens if somehow the current or your power supply in one of your pizza shop goes down, right? And yeah, I assume that you have open home deliveries. So if this goes down, what happens to the orders in this pizza shop? Because the users have paid their money, and you do not want to give them back that money. You want to give them back the pizza, right? So you need something, a central server which would handle everything of all these shops. So we implement something known as a database over here. So naturally, when your electricity or your pizza shop one is down, you want that these two pizza shop should take the responsibility, either of these, and should complete the orders of this pizza shop, right? Should complete the orders of this pizza shop. Now, what you can do is that every pizza shop, whatever order it receives, it stores it into a database, right? It stores it into a database with the order number, the order, the pizza shop number, and so on. Now, the moment a pizza shop goes down, the database still contains the orders of this shop, and so they can be easily distributed among this shop and this shop. That's what the use of database could be. Now let's look at something more interesting. So initially, you have scaled up very well, you're working very well, and now your person comes here with an order which requires extra cheese, extra toppings, extra perhaps mozzarella, everything. And so all of these orders is being handled by a single person or a single chef. A single chef is preparing the pizza directly from scratch. He is making the base, he is preparing that topping, he is adding the sauce, respective sauces, and he's baking that entirely from the scratch. So this person has to specialize in all of these techniques, and it is indeed a very nice idea. No, not a nice idea. So he has to specialize in all of these techniques. Now let's look at a different scenario. For instance, I have a pizza shop, and my person here has got different requirement. So if the requirement that he wants is, for example, extra cheese. So this person over here, he is concerned with preparing the base. This person over here is the person responsible for the cheese. This person over here is the person responsible for the toppings. This person over here is perhaps responsible for baking that pizza. Okay. So this person gets to the counter and he says all this, that he wants extra cheese, extra topping, the given topping, and so on. And so once he places this request to something which we will further be seeing as a gateway, this gateway forwards the result. So depending on the amount of base, it contacts the base. Depending on the amount of cheese, it tells the cheese person. Depending on the amount of toppings, it tells the topping person. And depending on the type of baking, whether he wants a fresh pan pizza or other pizzas, he will contact this baking part. Now once this base has been prepared, he would be passing this base to the cheese one. He'll be passing this cheese to the topping one, the base, after adding cheese, sauces, and so on. After topping, it would be added to the baking part. And finally, after all this process, you would be having your result of a final pizza. Now the thing is that these people independently make up the base, independently make up the cheese, independently make up the topping, independently do the baking, right? So these people can then specialize in these fields, and they can make a better pizza. They can also, since the work is divided into various people out here, the pizza can be made in a very short duration of time. And that is what brings us to monolith and microservice architecture. So as you can see out here, on a naive basis, monolith is this one single thing, or this one single chef preparing everything from pizza base to topping to cheese. Whereas, microservice is something which this huge thing or a huge function has been divided into this various groups out here. That's what the two differences are. So a monolithic application is actually a single tiered software application in which different components combined into a single program form a single platform. Microservice or is a different approach to an application, and in which a large application is built as a suite of modular services. So these were the two definitions. Let's look at this in a technical way. So this is what a monolithic architecture is all about. So let's, for example, we are dealing with Instagram, right? An architecture similar to Instagram. So in Instagram, what you can do is that you can like people's post, you can talk to people, you can, send requests to other people, follow requests, and so on. So, I am a client out here, right? I want to chat with a different person out here, and I want to also perform a follow request, give a follow request to a different person out here, right? So I place a request to this monolithic architecture, and what it is doing is that it is asking or inquiring about this function, and this entire machine is performing this function of retrieving from the database, and then it is then loading the chats, and then it is making you talk to this person. Now suppose if I want to make up if I want to send to a follow request, again I am sending it to this server. This server is then working and then retrieving from the database about this person, and then sending him a request, right? That is what the difference between a monolithic and what is a monolithic architecture. At every request, the entire architecture or the entire system is running. And let's look at a microservice architecture. So in a microservice architecture, you have got a request. Your gateway API is processing this request. Right? Now, based on what you want, it is perhaps if you want to make up, send a follow request to a person, it is telling it to access the database, and it is, performing a follow request in this task 1. If you want to chat to a person, you are communicating with the gateway API. It goes to the accessing the database, and from this database, you perform the task 2. So as you can see out here, task 5, task 4, and task 3 are not performed in this scenario. So you can see out here that the entire system is not working. Each system is working independently, and the user is only interacting with the gateway API and nothing else. It is only interacting with the gateway API and the gateway instead of the entire system or the server out there. So as you can see out here, this task 3 can also interact with the gateway API. For instance, if it wants to predict or perform machine learning, it wants the user's data. So it will interact with the gateway API or perhaps directly to the accessing the database, and then the final interaction would take place. So as you can see out here, this is what exactly a professional gateway looks like. An account service, there would be inventory service, a storefront web app, a shipping service, and you got different databases, perhaps a database sharding technique, which we'll be perhaps dealing in further videos. There is an API gateway for a mobile for a REST API, or a browser for a web app front web store web app. And let's discuss the difference between these two. So as you can see out here, single monolithic architecture is processing this request entirely. The entire architecture is working to perform that. Whereas in this scenario, only parts of these are working to perform the entire function out there. That's the difference. And one of the better things of Gateway API or launching this microservice architecture is that, people can specialize in task 1, people can specialize in task 2. They need not look at the entire process. If this task deals with, adding a backend support, so you can only work on backend support. You don't need to work on something which is, adding a front end application or a front end UI. So that's the beauty of, microservices all about. But there's one con, and that con is that it is not very easy to, split your service into microservice architecture. So, initially, if you got 10 to 15 people and you just started your project or a startup, you should do it in monolithic architecture. But, as soon as you have got people into your startup or your project and you want to scale up, you should get into this architecture. Though it's not very easy to break and it's not very easy to, segregate into different parts. Also, uh, almost all the data centers, Google, Facebook, Amazon, they use or implement, this architecture of microservice. There's only one popular architecture, and that's Stack Overflow, which, uses this monolithic architecture. Uh, so, if you like this video, please do subscribe, and if you want more videos, do let us know in the comment section. Thank you for watching.